hydrogen. Hydrogen just simply gets a dot. Next over, you can have, let's see what's a good color for that. Well, for 2 bonds, you can have, I'm doing the moon. Let me show up, need markers. Two bonds could be a moon. We did it as a football the other day. Magnesium, right, those. So it can be a football, or lastly, we even did for 2 bonds was a horseshoe. So these are all group 2. Hydrogen's 1, so lithium, all those guys. Now group 3, this is what we came up with the other day. For boron, we're going to give it the isosceles triangle so that you got the 120 degrees. Okay, so see that there's 3 bonds to that. So now when we come over next, first we got a carbon in between there, so that's the carbon diamonds here. Four bonds on the carbon, right? So, check our red. Our markers are disappearing here. What our colored pencil is, okay? So B with 3 bonds, hone in a little bit on this. So there's 1, 2, 3. These guys are 2. 1, 2. The football. 1, 2, or even the horseshoe. Now the horseshoe is cute, but it doesn't quite do the, because the geometry, you really want them on the opposite ends. So the moon was cool. We're trying to work on quarter moon because it's not 4. So here's 3 bonds. Carbon's going to have the 4. This would be methane, equivalent of. Okay, so what we just came up with, to give this to 120 degree, we made nitrogen. For 5, we're going to put 3 in paren because it's only got 3 bonds. So we're going to give it a right angle. And it's going to have 3 bonds, but then we bring in the lone pair on this. 1, 2, 3. So we put all the lone pair of electrons in there, though. Because that baby is able to bond other ways. Let's color some of these a little bit here. Carbon. Nitrogen, right? Nitrogen. Marker here. N. So see, the color coding works really good on this too. Black for carbons, and we do different colors on the carbon depending on the type of atmosphere that it's in. Single bond, double bond, etc. Boron, what's underneath boron? Aluminum. So So aluminum is going to do the same thing with the 3 bonds here. So you could say like aluminum, 3 bonds. So the aluminum like boron. Now this would be something like calcium, magnesium maybe, barium it could be. So this could be different number 2s. We got 3s, we got 4, we got 5. Now oxygen's really good because it's 6, but really it's 2. So when we draw O here, two bonds. So what's nice about the O is you draw many lone pairs in here. There's 1, 2. So it's like a double 2-headed alien. When it gets ionized, we draw a big number 3 in there, but for now, oxygen's always got the 2 bonds, so we'll kind of leave that as it is. Here's another green. We found all the best colors of these giant crayons in our recycle adventures. So again, kids, this is all from recyclable materials that we got here. From the crayons to the blueprint paper to the markers, except I did buy some new markers. So the aliens, you can color those in a little bit if you want. So again, the 2 bonds on the O here, what would those be? That'd be H2O, right? So 1, 2. That'd be H2O. Now underneath N, this is where our first great discovery came. Phosphorus markers. About these. Phosphorus has 5 bonds that it can do, or 3, but so see that? 5 bonds. Let's just use those, even though you never find this because it's too big. But 2, 3, 4, 5. So this is underneath underneath nitrogen. But then when we looked underneath oxygen, sulfur can have 6 bonds. So we came up with the old Star of David here. 6 bonds on that. 1, 2, 3, 4, 5, 6 bonds on sulfur. So isn't that neat how the star comes into play here? 5-pointed star for the phosphorus, 6 for the sulfur. This is fun stuff. And we're still working on it, but I think green has to be it because it's in the same family as the oxygen. There's sulfur, phosphorus. Now what we did for helium, we even found we can do it as a sun. Just since we're doing shapes here. So helium, it's just the sun. And our sun is actually a yellow. Yellowish orange our sun is. And don't let them tell you our sun is a typical star, because it is not by a long shot. For one thing, it's an independent. Everybody thing, it's an independent. Everybody else has pairs, binary, trinaries, 4, 5, 6 stars all in orbit. Ours is all by itself. So to learn the Schroeder diamond technique here, just simply learn what the valence is. Hydrogen is 1, calcium, magnesium, barium is at 2, 120-degree triangle is for the 3s, the diamond, carbon diamond is 4. Now these do different characters, so even nitrogen has 3 bonds. The phosphorus could do that, but we give it a 5-pointed star here. Oxygen, 2 bonds, 2 lone pairs. Sulfur could do the same thing, but it gets the equivalent of 6 bonds around here. Then what we do for the halogens is a square. So like fluorine, fluorine only gets 1. And we're still determining what to do about this lone pair thing, because put aliens on the corner. So this is HF. This would be hydrofluoric acid, right? So now when you do chlorine underneath, you still do it as a box. And what you can get is the equivalent for each lone pair here to be an O. There's an oxygen. The alien bonds to another double bonded oxygen. Alien here, another bonded oxygen, so we should make these bigger, I guess. That's the O. And what it still has is the single there. So what you're able to get now is a single bonded O. So that'd be hydrochloric acid. This would be HClO4. That's the biggest molecule you'd ever have to draw the Lewis structure for. So we color these halogens in, being kind of a purplish color. Like a little purple, so halogens are purple. Fluorine, see, this is HF. That'd be hydrofluoric acid. Because the atom is smaller, the lone pairs aren't able to bond like the bigger atom chlorine does. So everything underneath chlorine will do the same thing, have all these different possibilities. So you've got bromine and iodine will do the same molecules as that. So that's the premise here of the Schroeder diamonds. Look, we found all these colors in the dumpster. So color the phosphorus orange. You can draw anything. What you do now is you find a chemical structure in a book, and then you draw it yourself. Sulfur's yellow. And mix the media. Use colored pencils, use markers, use crayons. So sulfur, phosphorus, aluminum, 2, 1. 1, 2, 3, 4, 5 is 3 bonds, 6 is 2 bonds. Your halogens. One bond on the fluorine. When you get to the chlorine, bromine, or iodine,